Good afternoon. Today we are looking at the start of chapter 7, which is univariate and bivariate data. So previously we've been looking at univariate data, which uni, as in like unicycle, means one. So there's one variable involved. However, now that we're looking at bivariate data, we now have to work with two. Bicycle, so unicycle, one cycle, one wheel, bicycle, two wheels. So bivariate is two variables. And what generally happens is we have things called EVs and RVs. So what we have are explanatory variables. So these are explanatory variables are generally things we can control. If we were thinking about it in terms of on a graph, you've got your x-axis and you've got your y-axis. Explanatory goes on the x-axis. The response variable is something that changes in response to the EV. That usually goes on the y-axis, so it's called the response. The response variable. So they both use the same word, v, variable. So as part of this, we have to start thinking about, well, if we're comparing two things, what is the response and what is the explanatory? Which thing influences or causes the other thing? And one of the ones that teachers love to get to is comparing the amount of time a student studies with the amount of with the score that student gets on the test. And I think we can all generally assume that a student who studies for more will generally get a better result. So what we're going to do is we're going to figure out, well, how do we represent bivariate data? And the way we do that is with a scatter plot. All right, so what I'm going to do is I'm going to use the CAS behind me, and I'm going to put in some random numbers to represent the number of hours a student spent studying. And then I'm going to put in, for those students who studied this amount of time, what their score was. All right, now I'm making these numbers up, but the trend will still make sense. All right, because again, we agree, the more you study, generally, the better you're going to get. Now, the difference between univariate and bivariate data is that univariate data, that can be in whatever order you like because they're not linked to each other. But for bivariate data, the two numbers that are next to each other in this one column. So for example, this, what we can do is we can go into the list functions and we can change their names. So we can call this, well, we can call it time. And then we can call this one score. So time will be in hours. So the student who studies 3 hours gets a score of 45. All right, and that 3 and that 45 are locked together. They are a pair of results. All right, so I'm going to go through and I'm going to fill out the first 10, and then we're going to see where we go from there. All right, so I've got 10 students with their study times there, and now I'm going to put their scores in. So the student who did 12 hours is obviously going to do quite well. This is undefined because I haven't put anything in there. As soon as I put something in there, it will calm down. I now have 10 points of data. So what I'm going to do is, to get my calculator to do this properly, what I need to do is I need to go set graph and go into setting. And under here, I have a scatter plot. So I need to make sure that this says scatter plot, not NP plot or histogram or medbox like you've been doing previously. It needs to say scatter plot. So I hit scatter, and then I need to change my list. Now, because I changed the names of my lists, I need to make sure that in here, they say the correct thing. So time, I'm going to put along the X list, and then the Y list is going to say score. I'm then going to say set, and then I'm going to draw my graph. All right, and as you can see, I have my results are now plotted, and I can see that within reason, it goes up. So, see, there you go. So as you can see, it sort of starts down here, and it goes, as I go along, the values are generally increasing. Now, obviously, if I were to go through here and I would fill it out, I would get some results in here, some here, I might get one down here, I might get one up here, but by and large, you would say that there is an association between the amount of time someone studied and the score they got. All right, so scatter plots are the best way to represent bivariate data, and throughout this unit we're going to be playing with a couple of different things that rely on us understanding how scatter plots are made, and then we can decide how closely things are linked together, because as you'll find out, some things, because two things happen to be in correlation, doesn't necessarily mean that one causes the other. For example, if I told you that the amount of cheese someone ate correlated strongly with the odds of them dying in their sleep, being strangled by their bed sheets, you would be right to be skeptical. Doesn't seem like there would be some sort of link. However, the odds of you dying strangled in your bed sheets happens to increase the more cheese you eat. All right, so the questions that go with this are from 7A and 7B out of your Cambridge textbook.